What's up? What's up? It's your man, Jimmy Chan. So now we're talking about estimating a population mean. So what is the difference here? So in this case, we're taking an even smaller sample from the population. So before, when we were using the so-called z-score, we were using more than 5% of that population data, okay? But now, since we're using even less than 5%, then we're going to use the t distribution. So t is going to be less than or equal to 5% of the population. Okay, so that is the difference there. All right, so again, if we're using less than 5%, then we're going to use the t distribution. If it's more than 5%, then we're using the z. Okay, so that's what you need to know there. So again, just so you know, big N is the population size in terms of number of data for the population, while lowercase n is the sample size. Okay, so that's what we got to understand. So again, because okay, so because we are using smaller than 5% of the population size, that's why we're using the t distribution. If it's greater than 5%, then we would use the z. Okay, so this is no different than before, right? So before we would have to find the z value. Well, now we got to find a t value. And since we're already taking a small population, remember that this would be, if it was z, this would be z is equal to x bar minus mu divided by the standard deviation. But because we're using such a small sample size, remember that the standard deviation of that population is actually the standard deviation divided by the square root n. So that's why that part has all changed as well, right? So that's what we learned. However, this has a n minus 1 degrees of freedom. So if we were to look at the table, your table will have a t with the n minus 1 degrees of freedom. So you actually have to read the two columns to get the right number. So the degrees of freedom, or sometimes this is called just df for degrees of freedom, and that's what you're going to have to focus on, right? The x bar is a sample mean, and S is a sample standard deviation. Okay, so we need to understand that as well. So let me go ahead and highlight this in red. X is sample mean, and S is the sample standard deviation. Okay, so at least this way you have some kind of reference to what you need to look at when you're looking for everything that you need. All right, okay, and yes, the t distribution does follow somewhat of a normal distribution. Oh, that's the other thing I wanted to highlight. A simple random sample size n. Okay, so we're still doing the SRS. All right, let's go here. All right, so we still have a margin of error, so we're still looking for an interval, and it's still going to be that mean plus or minus some kind of margin of error. So the only changes here is that, now look at E. E is still the t of alpha divided by 2 times the standard deviation. Remember, the standard deviation changed to standard deviation divided by the square root n, right? So we still have the same exact thing, all right? Except the so-called standard deviation now is not with the point estimate, okay? Okay, so let's go ahead and go into an example. So here, the website Fueleconomy.gov allows drivers to report the miles per gallon of their vehicle. The data in Table 3 shows that the reported miles per gallon of a 2014 Toyota Camry automobiles for 16 different owners. So 16 different owners. Treat the sample as a simple random sample of all 2014 Toyota Camry automobiles. So again, when I talk about population size, I'm not talking about everybody in the world. I'm talking about, in this case, the population size is all 2014 Toyota Camry automobiles, right? All of their owners. Construct a 95% confidence interval for the mean miles per gallon, right? So last time we did proportion. Now we're talking about the mean miles per gallon, okay? So we're given this table right here of those 16 people that we saw. So we are going to need to find the mean and the standard deviations on our own, okay? So for the TI, what you would need to do is you will have to go, okay, let me do it this way. Let me erase this and say, so number one, do I want to just go there? Yeah, why not? So number one, find X bar and S, right? Okay, so with that being said, on the TI, what we would do is go into stat and then edit. And what we want to edit is the L1, right? So we're going to put all 16 data points in L1. Then you're going to go into stat, under calc. You're going to do the one var stat. Okay. Now on the Desmos, what you're going to have to do is hit the plus sign. Then you are going to hit table. And under X sub 1, you're going to enter all the data. Okay, after you do that, you're going to go ahead and go into your functions and then type in the mean, and you want it of X sub 1 because that's where you typed everything in, and the standard deviation of X sub 1. Okay, now there is a standard deviation P, which would be your population standard deviation, okay, which is different. So this one is S, where standard deviation P would be your sigma. Okay, so that is what the difference is here. Okie dokie. And with these two things here, what you will get, so I'll do this. You're going to get the X bar is going to equal to 28.1, and the S is going to equal to 2.38. Okay. So now that I have my mean and my standard deviation, my next step, step 2, is going to go ahead and find margin of error, which is E. So E is equal to my T of alpha divided by 2 times the S divided by the square root of N. Okay, now, let's go back up here because we need to find t somehow. And how do we find t? So over here, since we have a 95% confidence interval, we know that the alpha is equal to 5%, right? That means alpha divided by 2 Okay, let's do that. You box this. That should make an arrow. That's what it should make, is a box. Okay, so we know that alpha is equal to 5%. That means alpha divided by 2 is equal to 2.5%. So alpha divided by 2 is equal to 0.025. So I need to find t of 0.025. Okay, so that's equal to a so-called question mark. So how do we go about finding that? All right, so in a TI, you are going to do inverse t of the area. That's not going to let me do that. You want the area, comma, degrees of freedom. So in this case, inverse t of 0. Actually, you're probably going to have to do again, same thing, the 1 minus 0.025, comma, how many data points do we have? 16. So degrees of freedom is going to, let me show you. Let's do this. N is equal to 16. So degrees of freedom is equal to 15 because n minus 1. So that's why we would put the 15 in here. Now, of course, your question is, how about Desmos? Okay, Desmos is going to be a little bit longer, right? So that one's going to have to be the inverse CDF of the t distribution, and in that is going to be your degrees of freedom, comma, your area. Okay, so in this case, we're using the 15, comma, 1 minus 0.025. Okay? So that's how we would go about doing that. All right? Now, with that being said, what comes out to be our t of 0.025? That's going to come out to be 2.1314. Okay? All right, so now we can find the error or the margin of error, which is equal to 2.1314 times the standard deviation, which is 2.38, divided by the square root of n, which is 16. And when you put this in your calculator, you should get about 1.27. So to find our interval, so maybe this should be number 3. What do you guys think? That should probably be number 3. And number 2 is probably what we did here, right? This should probably be number 2. Find the t. Okay. So, you know what? Let's do that actually. Let's go ahead and bring the, oh no. Let's see. Okay. just gotta be very careful here. Oops. I said careful and I'm not careful. There we go. Then 3, right? So since this is my error, then my interval, so step 4, which is going to be my x bar plus or minus my e. Well, my x bar is 28.1 plus or minus 1.27. So in that case, I have 28.1 minus 1.27 and 28.1 plus 1.27. So here I should get 26.83, and over here is a 29.37. There we go. All right. So then step 5 is our conclusion. So the conclusion is that we are, let me rate that a little better. We are 95% confident that the mean miles per gallon for a 2014 Toyota Camry is between 26.83 and 29.37 miles per gallon. Okay. So that would be my conclusion. Now, again, this would be the work that you would need to show if you needed to show work. However, if this is for an exam that you don't have to show work, you can actually find these intervals here on the TI. You can simply put in the T interval, and what you'll have to plug in there is your X bar, so your S, your standard deviation, your N, your sample size, and your C level. If you type that in, you ought to get everything here. So the X bar was the 28.1, your S was your 2.38, your N was right here, which is your 16, and your C level was 95%, so 0.95, all right? And you ought to get the same thing. So you should be able to get the same exact interval there, okay? All right, next, again, we need, in case we need to find sample size, nice part about this one, there is only one equation, okay? And don't forget, when we're looking for sample size, we always round up to the next whole number. So we again consider the problem of estimating miles per gallon of a 2014 Toyota Camry. How large a sample is required to estimate that the mean miles per gallon within 0.5 miles per gallon with a 95% confidence, okay? So, again, the 95% confidence tells me I don't know why that makes an arrow. But this one right here tells me that alpha is equal to 5%. So alpha divided by 2 is equal to 0.025. Okay. And if you notice, because we're looking at sample size, right? So that means there is a very good chance that we're going to be going past that 5% of that population. So that's why it's using Z again. So we're not looking for T of alpha divided by 2. We're looking for the Z of alpha divided by 2. And if you remember correctly, I believe that is 1.96 if you look at the table, or you can do the inverse norm. Okay. Now, what is this within 5.5 miles per gallon? If I wanted an arrow and I tried to draw the box, it would never give me an arrow. But if I wanted the box, it gives me the arrow. So what does this give me? This is telling me that E is equal to 0.5 miles per gallon. All right. So let's find the size. The size is going to be, as you can see, Z of alpha divided by 2, which is 0.025, times the standard deviation divided by E squared. Okay. So if that's the case, then N is going to equal to this 1.96 times the standard deviation, which is way back above, which is 2.38, divided by my E, which is 0.5 miles per gallon, and then I can square this. And this is going to give me an 87.04, which means I'm going to go ahead and round it to N to equal to 88. And there we go. All right. Well, I hope this helps. If there's any questions, please let me know. See ya. Bye.